Hello, this is Chiban Acharya. Uh, Again, in this video, I'll do the homework from section 4.1, uh, which is scatter diagrams and correlations. First question is about the definition. What does it mean if R equals to 0? Notice that R is called correlation coefficient. Correlation coefficient. What do you mean by correlation coefficient is 0? That means if the correlation coefficient is 0, there is no linear relationship exist between the variables. The answer is there. Notice that there is no linear relationship. There could be other type of relationship might exist between the variables, but no linear relationship exists between the variable if R is 0. Question number 2. There is two relation here. Hours spent studying a week and GPA. Okay, hours spent studying and the GPA. And other questions, number of hours each week is spent on social networking sites and GPA. Okay, and notice that in the first relation, if you spend more hour, your GPA going to be more. And that means if the value of this variable spent studying week increases, the value of GPA also increases. Therefore, you're looking for the diagram which have a dot is going upward. Therefore, this is the right diagram where time studying is explanatory variable, GPA is a response variable. If you go right, you're going up and up. Okay, the answer is C. But this doesn't make sense because this goes down. It looks like more time studied, GPA is down. Technically not possible. This is everywhere. It's not even relationship between these two variables. Is not right answer either. Answer is C. Other one is just opposite. Number of hours each week spent social networking, GPA and GPA. If you spend more hour in social networking, you don't study, just looking at the social networking, your GPA goes down. Therefore, the answer must be C here also. And you can see that time on the social networking side increases, your GPA gonna be, which is y-axis, is down. Therefore, answer is C. Question number 3. Select the correct choice that complete the sentence below. In a scatter diagram, the variable is plotted on the horizontal axis and the other variable plotted on the vertical axis. Okay, therefore the explanatory variable plotted to horizontal axis and response variable plotted to the vertical axis. Or we can say this way, this is the explanatory and this is the response. Okay, response variable is in y-axis or vertical axis and explanatory variable in horizontal axis. Question number 4. Determine which set of the variables has a strong positive correlation and explain why this is so in such scenario. And here's different variables and you got to identify which two variables are strong positive. Strong positive. Notice that strong positive correlation and why. And here, look at the first one. Hours spent studying for the test and GPA. So there's strong positive relation because students that spend more time studying tend to have higher GPA. Obviously, this is the strong positive. More students study, GPA going to be higher. Therefore, this is the answer. A. How about the B? The car speed and the time it takes to reach the destination. So the strong positive correlation because faster the car travel, shorter it takes to reach the destination. Now this is the negative, because if car travel faster, distance going to be shorter. That means distance decreases as car travel faster. This is not the correct answer. This is the strong negative pretty much. Height and the weight. Remember that, children height and the weight. Height and the weight. So the strong positive correlation, because as the children grows up, both their height and weight increases. In other words, as height increases, weight of the children also increases. Therefore, this is also strong positive. And if you look at the D, this is a strong negative. That's not a strong positive. Question number 5. When all points in a scattered plot falls on the regression line, what's the value of the correlation coefficient? Describe what does it mean. If all points fall on the line, for example, if it is the line points, and if all points fall on the line, or other way around, if all points falls on the line. Okay, this is perfect positive, this is perfect negative. But here in this question, when all points in the scatter diagram falls on the regression line, the value of the correlation coefficient is, there are only two options, 1 and 0. Therefore, you have to pick 1 here. Okay, you have to pick 1. Could be -1, but there is no option to pick -1, right? Then the value of R is 1. That means there is a perfect positive correlation between the two variables. Remember that there could be -1 to be perfect, but it has to be perfect negative correlation. But since we have only option 1 and 0, you pick 1, and the value of R equals to 1. That means this indicates perfect positive correlation between the two variables. Question number 6. Fill in the blanks questions. A measure that is used to describe the strength and direction. Notice that strength and direction here of the relationship between the variables whose data points lies on the near the line is called R. That is called correlation coefficient. Okay, and the value of R goes from -1 to +1. Therefore, the value of R could be -1 and go to the right, bigger than -1, could be -1, and up to 1. And that could be, this is the could be possible value of the R. Therefore, R value range from -1 to +1 and could be 0. If 0, there is no relationship between the variables. Alright, question number 6 is that. Question number 7. What does it mean to say the two variables are positively associated? Negatively associated? What do you mean by two variables positively associated? What do you mean by negatively associated? That's the question. Positively associated means there is a relationship between the two variables. Whether the value of the one variable increases, the value of the other variable also increases. Okay, that is a positive associated. In this case, the dot goes like this, like that, like this. But negatively associated is other way around. There is a linear relationship between the variables, and whether the value of the one variable increases, the value of the other variable decreases. Remember that? If the value of the one variable increases, the value of the other variable decreases. That's the negatively associated. A scatter diagram for negatively associated looks like this. Like dot is going to be downward fashion like that. Okay? This is the positively associated. This is negatively associated. Here R is positive. Here is R is negative. Okay. Question number 8. Will the following variables have positive correlation, negative correlation, or no correlation? You have 3 options. You have to pick one. Or pretty much you drag this on the box. Correct box. Positive correlation, negative correlation, or no correlation. Which one is correct? Year of education and annual salary. What do you think? By the way, if you have trouble dragging, just drag this box by itself, make it bigger. Okay, by using this corner, drag the box, make it bigger, and just drag this option in bigger box. Okay, all right. Year of education and the annual salary. What do you think? And obviously, if people have a more education in the more year in the education, they have a more salary, right? That's what, pretty much these two are positively associated. Therefore, in these two variables is the positive correlation. Positive correlation. And the second one, outside the temperature and the number of people wearing a coat. Think about that. Outside the temperature, number of people wearing the coat. And if the outside temperature is more, number of people wearing coat is less, because more temperature is hot, therefore few people wear the coat. But if the outside temperature is less, this is the cold, that means number of people wearing the coat is more. Therefore these are negative correlation. Negative. Finally, outside the temperature and day of the week. They are not related. Remember that. In Monday, what is temperature? Because in Monday, temperature more or less, Tuesday more or less, doesn't matter. But these two are unrelated. There is no relation between these two, outside temperature and day of the week. Therefore, it would no correlation. Make sense? Alright, question number 9. Similar here, dragging problem. And here's different types of the scatter diagram. This is 1, 2, 3, 4 scatter diagram, and the R is given here. The R is the value of R is here. You can see this R is same R here, R -1 here, R -0.992 here. All are negative, by the way. And what you have to do is you just drag the correct value of R into the box. Okay, now let's see it. And if you notice here in this diagram, all are negative correlation, because see, scatter plot, the dot goes downwards, right? Therefore all are negative. But this is pretty much no relation, because it doesn't look linear here. Looks linear here if you think about that line from here. This looks linear, looks linear, looks linear. Okay, this is the perfect relationship, because all dot in the line, right? Think about all dot as in the line. This is perfect negative. Therefore here R equals to -1. Here no relation, R is 0 pretty much, but we don't have a 0. But this number here, look at this number, very close to 0. Therefore R here is 0.038 with the negative. All right, now this is more stronger than this one, because see, the dot is pretty close to the line. Here R is close to -1. Therefore R equals to -0.992. And then finally, left with this one. This is pretty much moderate negative. Therefore R must be negative 0.787. Okay, number 10. Determine whether the scatter diagram indicates that the linear relation may exist between the two variables. Here, we don't know what is the variable, but the one is response variable in the vertical axis, other is explanatory variable on the horizontal axis. Okay, and the question is there linear relationship exists between variable? Linear. Other type of relationship might exist, but we're talking about the linear relation. And think about this. If you think about this dot here, think about this dot. The trend of this dot is not linear. See, this kind of curve. You see that? Therefore, there is no linear relation exist between two variables because of the pattern of the dot in this scatter diagram. Okay, therefore first question is, do the variables, two variables, have linear relationship? The answer is no, because the data points, remember that each is called data points, do not have linear relationship because they do not lie mainly in a straight line. Could be other type of relationship may exist between the two variables but not linear, because these data points or dots are not on the line. And if the relationship is linear, do the variable have a positive or negative? Of course, there is no linear, I should say, relationship is not linear. Okay. Question number 11. For the accompanying data set, the data set is here, which has x variable and y variable. Draw a scatter diagram of the data. Okay, first part of the question. Part B, compute the correlation coefficient, and the correlation coefficient is called R. Okay, and part C, determine whether there is a linear relationship between x and y. There are three parts of the question. Draw the scatter diagram, compute correlation coefficient, which is R, and determine whether there is a linear relationship between x and y or not. Okay, I solved this problem using calculator. Also, I can see the scatter diagram on the calculator. I can find a correlation coefficient also using a calculator, TI calculator. And you guys need to be very careful what I do in the calculator, what button I punch to solve this problem in the calculator. Okay, alright, let's find the data first. This is the data. Notice that x, y, like an order pair. You can think as a 7, 8, one order pair, 6, 7, another order pair, and so on. The last is 9, 5. Okay, then how many order pair you have? 1, 2, 3, 4, 5. And we call n equals to 5. In other words, number of data equals to 5. You know, as a set of order pair, there is 5 order pair. Okay, now let's put the data in the calculator. Here's a calculator, TI calculator. Now to put the data in the calculator, we do exactly the same thing we did last time. Press start, press number 1, which is added, and since I have the variable x and y, I put first variable x in L1, second variable x in L2. Okay, therefore I clear the L1. I press enter to clear it. Now I highlight the L2 by using the arrow. Okay, and I clear it and press enter. It's going to be clear. Now my L1, L2 column is blank. Now I put the data, which is x, always the x variable in L1 and the y variable in L2. In other words, response variable in L2, explanatory variable in L1. Always I have to do that. Okay, L1 is explanatory variable and L2 is response. Okay, let's put the data in L1. Let's finish putting X variable in L1. Okay, you get 7, enter, 6, enter, 6, enter, 7, enter, 9, enter. Therefore, I put all 5 data in the L1, which is X variable. I go to the next column, L2. I put 8, enter, 7, enter, 6, enter, 9, enter, 5, enter. Okay, now I have a data in L1 and L2. Okay, and again X variable in L1 and Y variable in L2. Okay, now you have to be careful. To see this scatter plot in the calculator, you have to do something. Okay, watch carefully what I do. Since I want to draw this scatter plot, see there is a stat plot option under Y equals to. I have to find this option by clicking second the Y equals. I get the stat plot and I select 1. Okay, now this has to be on. If your highlight is blinking on off, you use this arrow to bring your cursor in on and on it, and you go to the type, and this is the type. It should be highlighted. Press enter, and if you enter, you see this X list L1, Y list L2. That's what you did. Remember that you put X data in L1, Y data in L2. By default, it shows you L1 and L2. Therefore, I always suggest you to put the data in L1 and L2. Okay, mark doesn't matter. You have this mark as a dot, but I keep it like this. And what you have to do is notice that this has to be on, this must be highlighted, and you guys has to see X list L1, Y list L2. And now go to the zoom and you do number 9. That is zoom is start option, or you can scroll down and find number 9. See zoom start and press enter, and you see this scatter plot. And if you look at this question, which scatter plot is similar to this? Obviously this one. See, 2 dot top and bottom, 2 dot top and bottom, and this one here. Okay, and the answer for this question is C, part A, which is C. Part B, compute correlation coefficient, which is R, and the question pretty much asking what's the value of R. Round to 3 decimal places is needed. Okay, to find the R, you have to use a calculator again. There is another way to do it using formula, but I prefer to use calculator because this is quicker. To find R, again you have to do something before you will find R in the calculator. Okay, to see R in the calculator, you have to do this first. You do second and press 0, which brings you catalog. Okay, now under catalog you have to find diagnostic on. Scroll down until you find diagnostic on with the D. Let's see, diagnostic on. See, this arrow pointed to diagnostic on here, and you press enter, and it said diagnostic on, and it's blink here. Press enter again, and it said done. And when you get done, you're good. Alright, now you have to go to the stat again and select calc, okay, and here you have to select number 4, which is line reg ax plus b, number 4 option. Either you can scroll down and select 4, or you can type 4, okay, enter. Then you say line reg ax plus b, and since your data is in L1 and L2, you don't have to do anything, and you press enter. If you do that, you see here R. This is the value of R we're looking for, and as a 2 decimal places, if you round, are going to be negative 0.387. Okay, that's the value of R, 0.387, 0.387 with a negative. All right, and part C, determine whether there is a linear relationship between x and y. Okay, to see that, you got to find the absolute value of R. Since R equals to negative 0.387, absolute value of R going to be absolute value of negative 0.387, which is going to be 0.387. Basically, absolute value of R is positive. Obviously, you can see that. Since this is negative R, absolute value of R is positive, obviously. Now, what happens is, to see the linear relationship exist or not, you're going to find the critical value now. What's the critical value? Critical value, I should say CV, critical value is given, always given for you in the problem. And you can see that for n equals to 5, because there is a 5 data set, critical value going to be 0.878. Okay, therefore here critical value is going to be 0.878. Let me write down for you. Critical value CV equals 0.878 for n equals to 5. That is always given for you. Let's compare absolute value of R with critical value. Let's compare. What is the absolute value of R? 0.387. 0.387. What's critical value? 0.878. That means absolute value of R is less than critical value. Right? You can see the absolute value of R is less than critical value. That means there is no linear relationship. In other words, there is only linear relationship if absolute value of R is greater than critical value. But since here is less than critical value, there is no linear relationship. How do you answer the question? Because the correlation coefficient is negative, and the absolute value of the correlation coefficient is 0.387, which is less than, okay, less than the critical value for this data set, which is gonna be 0.878. You see that for this data set n equals to 5, critical value going to be 0.878. Therefore, there is no relation exist between the variable. Okay. Question number 12 is similar to question number 11. I'm not going to do that. They're exactly similar. And question number 13 is also similar too, but I want to do this one. Again, make sure that you do diagnostic on. Make sure to do diagnostic on, and stat plot on in the calculator. Okay, now again, if you want, you can watch the homework video, question number 11. How do you draw the scatter plot and how do you find the R? Okay, I'm gonna do this question number 13 now. To do that, I'm gonna open the calculator. That's the calculator here. Let's put the data in the calculator first. How do I put the data in the calculator? As you know, you have to start with stat and number 1. And since I have data in L1 and L2, I prefer to put in L1 and L2. Let's clear L1, L2 data. That's clear. And go back and select L1. Clear L1 data. It's gone. Now let's put the data. Note that this data is going to be L1, which is X data, and this is going to be L2, which is Y data. Because commit time here is explanatory variable and the well-being score is response variable. You always put response variable in L2, explanatory variable in L1. The calculator is here. Now let's put the data. Put L1 under L1, put X data, which is commit time. Under L2, put Y data, which is well-being score. I pause the video and I'll put data and come back. Alright, I put the data in the calculator. Let's answer the part 1. Which variable is likely to be explanatory variable and which variable is response variable? As I mentioned before, the explanatory variable is commit time and response variable is well-being score, because commit time affect the well-being score. Okay. Part B, draw a scatter diagram of the data. Again, since your data is in L1, L2, your stat plot is on, as you did in question number 11. What you have to do is just do zoom and number 9, and thus you see the data. Now, to find the correct data, let's see which data is similar to this scatter plot. Obviously C. Of course this is pretty similar, but you have to check well-being score with 100 is 63.6, but here in this scatter plot this dot doesn't correspond to 110, right? Sorry, 100. Therefore this must be correct scatter plot C for this data set. Now next question is determine the linear correlation coefficient between commit time and the well-being score. And to do that, you have to do stat calc number 4. Okay, since your data is in L1 and L2, you are good, and make sure that your diagnostic is on, like in question number 13, and press enter, and you see that the value of R here is minus 0.9927. Okay, but if you round it to 3 decimal places, you're gonna get 0.993 with the negative. Therefore R gonna be 0, let me write down with my pen, not the highlighter, negative 0.993. Make sense? Now, does the linear relationship exist between the commit time and well-being score? That's the question, last part of the question. Answer is yes, because we have to check absolute value of R first is going to be negative 0.993 absolute value, which is going to be 0.993, which is absolute value of R is 0.993, right? This is 0.993, but what's the critical value? Let's see how many data here. 1, 2, 3, 4, 5, 6, 7. Here n equals to 7. And what's the critical value for n equals to 7 is here. N equals to 7, critical value going to be 0.754. Right? What's critical value for this? critical value CV equals 0.754. Okay, here you go, 754. Now since absolute value of R here, you can notice clearly absolute value of R is greater than critical value. See, absolute value of R is greater than critical value, definitely. Therefore, there is a linear relationship exists between the variable. How did you answer the question? The answer is yes. Yes. Yes, the variable commute times and well-being score are negatively associated because R is negative, and the absolute value of the correlation coefficient is greater than the critical value, which is, you can see from the table, 0.754. Therefore, there is a linear, again, there is a linear relationship exists between the variable, which is commute times and well-being score. Question number 14, which is similar to question number 11 and 13, we just did it. Therefore, I will skip that. I'm going to do next question here, which is going to be question number 15. Even this is similar to previous question, I want to do this one. Okay, the accompanying data represent the speed at which the ball was hit miles per hour and the distance it traveled in feet. There is two variable here, speed and the distance. Unit of speed is mile per hour, unit of distance is in feet. Okay, here is a data, baseball data here, speed and the distance. Okay, and let's see how many data here. You need the number of data in this data set. Does it say here how many data? It doesn't say how many data here. Let's find it out. 1 2 3 4 5 6 7 8 9 10 11 12. For n equals to 12 here. Okay, 12 data. Now if you look at this data here, one is distance and speed, two variable, but you have to answer which one is an explanatory variable, which one is response variable. But notice that how far the ball traveled, I mean how far the baseball travel depends on what's the speed of the ball. Technically, more speed, distance travel gonna be the more. Therefore, speed, distance depends on speed. Therefore, distance is the response variable, which is in y, and we put this in L2, and speed is explanatory variable, which is x variable, we put in L1. Therefore, to answer the first part of the question, researcher want to determine if the speed with the ball which the ball hit may be used to predict the distance the ball traveled. Based on the research goal, what is the explanatory variable? Again, we mentioned before, explanatory variable is speed. Okay, draw the scatter diagram of the data. Choose the curve graph below. To do that, let's put the data in the calculator. Okay, again, you start number 1, which is edit, and you go clear the data in L1. I didn't want that. Just highlight it L1 using this arrow button, highlight and clear, and enter. That's gone. And go to the L2, clear, enter. That's gone. Let's put the speed in L1 and distance in L2. I'll put the data and come back. Okay, I put the data in L1. Let's find the scatter plot. For that, I have to go to the zoom. Again, make sure that your start plot is on as you did in the question number 11. You go to the zoom number 9, and you see this is the correct scatter plot, and corresponding to this scatter plot we have this data B. Okay, you just match, okay, with the dot, with this dot, with match with this dot, you'll find that this is the right scatter plot. Answer is B. Now determine the linear correlation coefficient between the speed and the distance, okay, between speed and the distance. That's the C. That means find R. That's the question. And to find the R, you go to start and calc number 4, which line reg ax plus b. And since your data is in L1 and L2, you have to do nothing. Enter. You see R here. And if you round it to 3 decimal places, as the instruction says, you put 0.812. That's the R. Therefore, R going to be 0.812. That's the R. And the question is, does the linear relations exist between the speed at which the ball hit and the distance the ball traveled? Okay, notice that critical value here, in this case, going to be for n equals 12, critical value going to be 0.576. You see here, 0.576. Therefore, critical value in this case is 0.576. And the absolute value of R, which is absolute value of R is 0.812. The same thing, because this is the positive R, absolute value is obviously positive. Okay, let me write it down. Absolute value of R is 0.812. And obviously, since absolute value of R is greater than critical value, you can see that the number, critical value and absolute value of R, you compare these two numbers, absolute value of R is greater than critical value. Therefore, there is a linear relationship exists between the variables. Okay, yes. And the answer is this. You fill in the blank question. The variable speed at which the ball hit and the distance the ball travels are positively associated because R is positive and the absolute value of the correlation coefficient is greater than critical value, which is 0.576. Okay, that's the answer for part C. Oh, sorry, part D. And part 16 is similar to 15. I'm not going to do that. That's all about section 4.1 homework. 4.1 homework is done. I hope you understand this video problems. Thank you for watching. Good luck.